Hey everyone, today we're going to talk about rational expressions. Now a rational expression is a fraction. It is a fraction that has variables and polynomials, which is kind of what sets it apart from a traditional fraction. Right, examples of rational expressions are 2x over 7, x plus 3 over 4, x plus 8 over x squared plus 10, x squared plus 5x plus 6 over x squared minus 4. These are all examples of rational expressions. Now, a traditional fraction, for example, is something like 24 over 32. Right, remember how you reduce a regular fraction. 24 and 32 are both divisible by a couple of numbers. 2, 4, they're divisible by 8, which is going to be the largest common divisor, largest common factor. So 24 over 32 reduces to 3 over 4. Now, when we reduce a rational expression, we have to think about reducing in a different manner. So let's look at the same fraction, 24 over 32. Now, instead of reducing it by dividing, let's reduce it by factoring first and then canceling. Right? And by factoring, remember, factoring is writing out the same expression, in this case the same number, as the product of two different numbers. So if we write out 24 as 8 times 3, and we write out the number 32 as 8 times 4, well, then these can cancel out. Right? They cancel out because they're the same on top and bottom. And we're left with 3 over 4. So when we reduce a rational expression, we are not going to be finding what divides evenly into x plus 8 and x squared plus 10. Or we're not going to find what divides evenly into x squared plus 5x plus 6 and x squared minus 4. But instead, we're going to be factoring, and then we're going to be canceling. All right, those are the two main steps to reducing a rational expression. Now, one thing that is very important, a very common mistake, if we have a fraction that says 2 plus 6 over 3 plus 6, for instance, it looks like that the 6's can cancel out, which is something very common that I see like this. This is 2 plus x over 3 plus x is a rational expression. And one thing that I see very, very often is that, oh, can I cancel out the x's? And this is equal to 2 over 3. In fact, it is not, because this canceling is incorrect. Right? 2 plus 6 over 3 plus 6 can actually be added together to get 8 over 9. And 8 over 9 is a fraction that does not reduce. So that is kind of one example showing you that there is a major pitfall with trying to reduce and trying to simplify where you can't. All right, so a main rule of thumb is you can only cancel out factors. And remember, factoring is writing out the same expression as the product of two different expressions, or the product of two different numbers. And the key word is product. Factors are separated by multiplication. Terms like here have 2 and x and 3 and x separated by addition, right? If they're separated by addition or subtraction, then it cannot be canceled. Factors are never going to sit next to an addition sign or a subtraction sign. So an example of that is that 2x and x cancels out. That's because this over here is 2 times x. The multiplication is not written, but it is there. So 2x over x reduces to 2. But if this 2 and this x are separated by a plus sign, or they could be separated by a minus sign also, doesn't matter, because this will not reduce to a 2. These x's here do not cancel out. That is not true. So you leave it alone. And one thing about factors is that binomials, such as x plus 1, right over here, this constitutes a factor, a single factor. So if we were to try to reduce 5 times x plus 1 over x plus 1, in fact, these x plus 1s entirely can cancel, and our answer is simply just 5. Let's take a look at some examples. Remember, we're factoring first, and then we are canceling. So 30x squared minus 150x divided by 35x. Up here, we're factoring, and again, factor means GCF, means AC method, whether A is equal to 1 or A is greater than 1, right? Remember, those are, what's happening again? Those are what we do for quadratics. And then there's also difference of perfect squares. So the instructions being to factor first means all the methods of factoring. So let's take a look at this 30x squared minus 150x. Right, there's a greatest common factor up top, and that's 30x. X minus 5 is left in the parentheses, and on the bottom is 35x. Now what cancels? X and x cancel. This x and this x do not cancel. For one reason, this x is sitting inside parentheses, so it cannot be crossed out with an x that's outside the parentheses. Also, this x is sitting next to a minus sign, which means also it is untouchable. This x, however, is sandwiched in between 2 multiplication symbols. So those can be crossed out. And 30 over 35 can be reduced just like a regular fraction. Divide by 5, and that's equal to 6. Divide by 5, and that's equal to 7. So if we bring it all together, that's 6 times x minus 5 divided by 7. And this is your final answer. There is no need to distribute. Just leave it in factored form. Let's look at number 2. Similar problem. We can find the greatest common factor between 27 and 243, and that is going to be 27. We can find the greatest common factor between x squared and x to the first, and that is going to be x. And then we can divide to get 27x squared divided by 27x is x to the first, and that's going to be minus 9. On the bottom, that's 15x. So once again, x out here crosses out with x out there. 27 over 15 can reduce to, well, let's not use red. Divide by 3 is equal to 9. Divide by 3 is equal to 5. So our final answer is 9 times x minus 9 divided by 5. Once again, leave your answer in factored form. So in a case where you have a expression up top that needs to be factored, we can factor that. That's going to say 24x squared minus 24x. (24x) is the greatest common factor. And remember, 24x divided by 24x is equal to 1, or in this case, -1. On the bottom, there is a separate greatest common factor. So pretend like you've got a worksheet. Number 1 said to factor this, and number 2 said to factor this. Right? You're going to factor them independent of each other, right? Just because the GCF on top was equal to 24x, that's going to have no bearing on the greatest common factor on the bottom. On bottom, the greatest common factor is going to be 42. And since this is just a plain old constant number 42, that means x is not part of the GCF. So we're getting 24x times x minus 1 over 42 times x minus 1. Now, like I told you before, x minus 1 and x minus 1 are factors. That means they can be canceled out. The entire factor can be canceled out because they're the same on top and bottom. Over here, 24 and 42 reduces as well. It's going to reduce by 6, so 24 divided by 6 is 4. 42 divided by 6 is equal to 7. And that brings us to 4x over 7. (7x) on top is not going to reduce, not going to factor, but 42x squared plus 35x probably will. So let's start with that. Greatest common factor between 42 and 35. That's equal to 7. Between x squared and x, common variable is going to have the smallest exponent be the greatest common factor. So if we divide this out, 42 divided by 7 is equal to 6. And then there's one remaining x because we only factored out one of them. Plus 35x divided by 7x, that's going to be a plus 5. 7x remains on top. So 7x and 7x can both cross out. The 7's cross out. The x's cross out. Now, when you cross out, you are doing division. X divided by x is equal to 1. 5 divided by 5 is equal to 1. 7x divided by 7x is equal to 1. That means our answer is not just 6x plus 5. Our answer is 1 over 6x plus 5. This is also a very common mistake. The common mistake is writing 6x plus 5 as your answer, right? This is wrong. Your answer is 1 over 6x plus 5. There's a couple of ways to think about it. One of them is that you are dividing, which means 7x divided by 7x is equal to 1. The other way to think about it is that 6x plus 5 is in the denominator. So when you are answering and putting in your final answer, 6x plus 5 has to remain in the denominator. So make sure that you are following those rules. There's a couple of pitfalls that can occur. So now something a little more complicated, but the rules are the same. So our directions are to factor 3x squared minus 24x minus 27. First of all, there is 3, 24, 27. There is a greatest common factor of 3. So the top becomes 3 times x squared minus 8x minus 9. On the denominator, there is a traditional greatest common factor. Well, I wouldn't say traditional, but there is a greatest common factor and that greatest common factor is going to be 2x. What we're left with is x minus 9, after we factor out that greatest common factor of 2x. So does anything cancel out? 3 over 2 does not cancel. There are no x's on top to cancel out with that x on bottom. And looking at this entire binomial, looking at the entire quadratic and the entire binomial, nothing there cancels. But if we focus on this a little more, x squared minus 8x minus 9, this quadratic that resulted after we factored out the greatest common factor, this is a factorable quadratic. So one of the things that I did not write but is implied is, didn't want to move all that over, that this step of factoring you have to factor completely. And that means that if you factor out a greatest common factor, maybe there's more to do, right? If we look at x squared minus 8x minus 9, there is more to do. And this is factoring. This is not solving. So the quadratic formula is not going to save you if you are having trouble factoring. So x squared minus 8x minus 9 factors into, this is the a equals 1 scenario, of a quadratic. So x and x, what multiplies to negative 9 also adds up to negative 8. That's going to be minus 9 and plus 1. And remember, this x minus 9x plus 1 was born out of this quadratic. That means this 3 is still in front. And on the denominator, we factored that completely, because there was nothing left to do. So, what changed now? 3 over 2x still doesn't reduce, but x minus 9 and x minus 9 do cancel. So that can cancel out. And our final answer is going to be 3 times x plus 1 divided by 2x. And this is what we're going to box in. So let's try another. All right, this is a quadratic, 2x squared plus 24x plus 72. So this is going to factor 2 times x squared plus 12x plus 36. On the denominator, 5x times x plus 6. Now, once again, nothing cancels here, but this quadratic means that there's more to do. So 2 times what multiplies to 36 adds up to 12. Excuse me. That's going to be a plus 6 and a plus 6. 5x times x plus 6. So we have these binomials of x plus 6 that cancel. Now, when you cancel, has to be 1 and 1. That means you can cancel out one factor on top with another factor on bottom. This 1x plus 6 is not going to cancel with both of these x plus 6's here. All right, so we only have 1 on bottom, so that cancels out with 1 on top. And that means our answer, 2 times x plus 6 divided by 5x, is our final answer. And once again, there was no need to distribute this 2. You can leave your answer in factored form. Okay, so 2 more. We have some more factoring to do. Looks a little complicated, but again, the first rule of factoring is to always look for a greatest common factor. always look for a GCF because it will make your life easier if it's there. So on top, 6 times x squared plus 8x minus 9. On bottom, 5 is the greatest common factor. And x squared plus 3x minus 4 is what's left inside. Now, once again, nothing's going to cancel, right? Inside the parentheses, they must be exactly the same in order to cancel. And since they're not, then you can't do it. But there is some AC method factoring to be done. And thankfully, factoring out this a equals 6 turned this into a simpler quadratic. X plus 9 and x minus 1 is going to work because 9 times negative 1 multiplies to negative 9, adds up to a positive 8. And remember, we are not using the zero product rule. We are factoring, we are not solving an equation. So 6 goes in front because it stays there from before. And the same for the same reason the 5 goes in front of the denominator. And this factors into x plus 4 and x minus 1. So what we should expect here is for something to be the same, at least the binomials, like this, or maybe over here, or maybe over here. But if there's only one set that cancels out, that means there's only one set that cancels out. We cannot force anything to cancel out if it doesn't. Part of being good at factoring is also the same thing as being good at simplifying radicals and reducing fractions. You have to know when to stop, right? And you stop when there's nothing left to cancel. Now, again, it looks like x and x can cancel out, but there are some rules that are preventing that from happening, mainly that they're next to plus signs. So one more. Let's look at this one. 4 is the greatest common factor on the top. X squared minus 7x minus 8 is the result of that factoring. On the denominator, 5 is the GCF. X squared plus 4x plus 3 is the result of that GCF factoring. So x squared minus 7x minus 8 is going to factor into x minus 8 and x plus 1. 4 is still out front. X squared plus 4x plus 3 factors into an x plus 3 and also an x plus 1, right? Because 1 times 3 is equal to 3, 1 plus 3 is equal to 4. That's why we are using these two factors here. 5 was in front before, and it stays in front right now. So what's going to cancel? Let's use another color because we're in the mood for whatever this is. X plus 1 cancels out with x plus 1. 4 times x minus 8. Oops, that's should be a minus. And 5 times x plus 3. So this is your final answer. If you decide to distribute that 4, and if you decide to distribute that 5, you will get the same amount of points. Right? You will not get additional points for doing that extra work, but the answer will still be correct. Thank you for watching this video, and